All right, so we are on page 252, identifying figure number patterns. So let's look at number 1. It says draw the 3 next rectangular numbers. Now, if you notice the pattern that they give you, and I'll zoom in a little bit, each time you are adding a row and a column. So if you look here, here's where we started. And the next number, we added a whole row and a column. Same thing. Here was the array from before, and now we're adding a whole row and a whole column. Here is the array from before. We added a row and a column. So what we have to do is we have to first copy this array. So now I'm going to fill in. So this array is showing 4 by 5. Now I have to add a row and a column. So here was the array from before, and we added a row and a column. So they want us to do this again. So now my array is it would be 6 by 7. And then I would fill everything in. So if this was 6 by 7, if this was the original array from before, and then we added the row and the column. So for the final one, if this shows 6 by 7, then the next pattern is 7 by 8. So I would do 8 across and 7 down. Okay, so I'm just going to fill in the rest of this array. But as you can see, all of the arrays that we had to do all form a rectangular shape. They are not perfect squares. They form a rectangular shape. So if this was the array from before, the next triangular number would be forming another row and another column. So that's what your pattern should look like for the next 3 rectangular numbers that would be in that sequence. So now let's look at number 2. It says complete the list of the first 10 triangular numbers. So I'm actually going to show you guys this on a separate sheet of paper, or I might be able to actually just squeeze it in over here if I make my pen a little bit smaller, because I just want to show you something. So the pattern is you have to multiply the counting numbers, and I'll show you what that means. So this 2 represents 1 times 2 would give you 2, and that shows that array. The next array would take that 2 and use and multiply by the next counting number. And if I counted 1, 2, 3 comes next. So now it becomes 2 times 3, which is 6. And if you counted these dots, this would be 6. So now I'm going to keep the 3. What's the next counting number? 1, 2, 3, 4. 3 times 4 is 12. So that shows this array. 4, so I'm keeping the 4, and the next counting number, if I counted in order, would be 5, and I get 20. If I counted all these dots for the 4th array, I would get 20. So now I'm going to keep going. So as you notice, I'm using all of these numbers. This is how you find a rectangular number. You multiply by the next 2 counting numbers. So for example, here's 5. 1 counting number, the next one would be 6 for the second, which would be 30. If you counted all of these, you would get 30. Keep the 6. The next number in order, counting number, would be 7, and you get 42, which is here. If I kept the 7, oh, hold on one second. All right, sorry about that, guys. There was somebody at my door, so hopefully I'm able to put these 2 videos together. So then I started off with 7, and the next counting number would be 8. And 7 times 8 is 56. So here's our next counting number. So then we would do 8 times the next counting number, which is 9. And that's 72. The next counting number, so it's 9 times the next counting number, which is 10, and you get 90. And finally, the 10th rectangular number would be 10 times the next counting number, which is 11, and you would get 110. So here's how you find all of the first 10 rectangular numbers. Okay, how did we get our answer? Well, I kept multiplying the next 2 counting numbers. And then I'll give you an example. I knew 42 equals 6 times 7, which shows this array here. So to find the next rectangular number, I multiplied 7 times 8, which gave me 56, which shows the 7th rectangular number. Okay, so that's a little bit about the pattern. So let's look at number 3. And the directions say continue the following pattern. So I see 2 equals 2, 2 plus 4 equals 6, 2 plus 4 plus 6 equals 12, and I already know that these are all examples of rectangular numbers because we did the arrays up here. And I know that this is a rectangular number because it comes next in our pattern. So now we have to figure out to fill in the missing blanks. And I also notice that the numbers all stay and you just add to it every time. So I'm assuming if there is an 8 here, then there should have been an 8 here to continue that pattern. So let's see. I know that 2 equals 2, 2 plus 4 does equal 6, and then it looks like they took this number and put it here. So 2 plus 4 plus 6 equals 12. Well, if 2 plus 4 plus 6 equals 12, how much do I need to add to get to 20? Well, I know that 12 plus 8 would give me 20, so that's where this number must come from. And you can see the number then repeats. So we have 2, 6, 12, 20. What's the next number in our rectangular number pattern? It's 30. So I'm going to put 30 here as my total. And if 2 plus 4 plus 6 plus 8 equals 20, how much do I have to add to get to 30? Well, I know I have to add 10. So I'm continuing this pattern. Now, all of these are blank. So to continue the pattern, I have to write down all of the add-ins from before. So 2 plus 4 plus 6 plus 8 plus 10. And I know my next triangular number is 42. So I know my total has to be 42. And if 2 plus 4 plus 6 plus 8 plus 10 equals 30, then I have to add 12 to get to 42. So if you notice that each rectangular number is the sum or the total of the even numbers in order starting with 2. So as you can see, all of these are even numbers. So to get the next one, the next rectangular number, I would add all of those, which gives me 12. To get the next rectangular number, I would add all of these, and that would give me 20. And then you would keep going. So each rectangular number is the sum. Remember, the sum is what is the total of numbers you add together of the even numbers in order, starting with 2. Okay, I want you guys to skip, oh no, sorry, not skip C. We're going to skip D, so you can actually just put a cross through it now because I want to do more review of square numbers before I have you answer that. So it says, what do you notice about the number of add-ins and the rectangular number? So remember, an add-in is a number you're adding. I'm just going to erase my highlight because I'm going to have to highlight again, and I'll fill in the numbers I left off. I just erased. Okay. So what do you notice about the number of add-ins? So that's how many numbers you're adding. So here, there's only one add-in because you're not adding any number. And this is the first rectangular number. 2 is the first rectangular number. So now let's look here. There's 2 add-ins here. And this is the second rectangular. The sum is the second rectangular number, 6. So let's look here. You're adding 3 numbers here, and 12 is the third rectangular number in order. All right, let's keep going and see if our pattern still makes sense. Here, there's 4 add-ins, 4 numbers you're adding, and it's the fourth. 20 is the fourth rectangular number in order. And if you forget the numbers in order, they have them here on number 2. Okay, here's 5 add-ins, and it's the fifth rectangular number. 30 is the fifth rectangular number. So that's the pattern that I'm seeing. The number of add-ins is the rectangular numbers place in order. So 2 is the first rectangular number, 6 is the second. I'm just following the pattern every time. So the number of add-ins, the numbers you're adding together, is the same as I'm going to put number in quotes here, the number of rectangular numbers. And whatever that means is 2, 6, 12, 20, 30, and 42. These are the first 6 rectangular numbers in order. And if you notice, here's 2. It's the first add-in. To get 6, it's 2 add-ins. To get 12, it's 3 add-ins, and it's the third number in the sequence. To get the 4th number in the sequence, you're adding 4 numbers together. To get the 5th number, you're adding 5 numbers together. Okay, so we're actually going to talk about triangular numbers as more of a challenge in the next math journal video.